In this video, we're going to take a look at some congruent triangles. Now, this is going to be the first video out of many. Probably the next 2 weeks, we're going to talk about congruent triangles. This week, we're going to focus on identifying which ones are congruent triangles, which ones are not congruent triangles. Next week, we're going to get into actually you building some proofs out on your own. So here we go, congruent triangles. Before we jump into that, before we jump into exactly which ones are congruent, which ones aren't, let's talk about this first. How many parts are there in a triangle? So go ahead, see if you can come up with an answer. If you're thinking about a triangle, how many parts are there in a triangle? Well, if you're thinking about this, kind of how I would be thinking about this, I would say that there's 3 sides, right? We have a triangle, has 3 sides, but that also creates 3 angles. So in a sense, in each triangle, there's 6 parts. There's 3 angles, 3 sides. Now, if I was going to have congruent triangles, what I would need is the 3 sides to match the other 3 sides, and the 3 angles to match the other 3 angles. So something like this. Notice here, I've got some congruent triangles. I know all the sides match. I know all the angles match. Now, here's a question for you. What if I took out one of these angles? So now I know 3 sides are congruent and 2 angles are congruent. Could we still know for sure that these are congruent triangles? Well, hopefully you recognize that, yeah, we still know these are congruent triangles for sure for a couple reasons. One, we know that these 2 angles and these 2 angles match, and since they both add up to 180, whatever this one is, it's got to match that one. And then 2, everything else is you could kind of think of it like it's just all locked in place, okay? So I removed one of the guaranteed joints, but the rest of it's locked in place. It's not going anywhere. Well, what if I take out a side? Okay, so now taking out an angle and a side, would those triangles still be congruent? Yeah, I think so. Okay, what if I took out a 3rd piece? Okay, how many pieces could I keep taking out and still know that they're congruent triangles? Certainly when you get down to, say, like 2 pieces, let's say we just keep taking pieces away, all right, we don't know for sure that these are congruent triangles. Maybe they are, maybe they're not, but I don't have enough information to tell. So we want to know how many pieces can we keep taking away and still know for sure that we have a triangle. And the answer there is actually we can take away 3 pieces most times. Most times I can take away 3 pieces and still end up with congruent triangles, but sometimes it doesn't work. So we're going to go through different types of ways that I could have certain information about my triangle but be missing other information and still know the triangles are the exact same size. So the first way we can tell if triangles are congruent is by what we call side, 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 or SSS. If I know the 3 sides of one triangle match the 3 sides of another triangle, then I know for sure that these 2 triangles are congruent. And this should make hopefully a little bit of sense. There's only so many ways you can put a triangle together, and if you have all the board lengths, you're going to end up with a triangle with the same lengths, and then the angles are going to have to match. So if we think about this just kind of in a real world scenario, we're not going to prove each of these, though we could prove each of these outside of the postulates. We're not going to worry about doing that in this class. Maybe if we were in person, be able to get to that. But for now, we're just going to focus on identifying, and then next week we'll get into proving. So side, side, side. I know if I have 3 sides that match 3 sides, even if I don't know any of the angles, then I know these triangles are congruent for sure. Now, before we go any further, we need to talk about something. Say you're living in an apartment. Okay, so usually the way apartments work, you have a couple different buildings, one building, couple different apartments all connected together. And one of the things about living in like a duplex or an apartment or something like that is that there's some shared walls. And so if you play your music really loudly, you can be heard through the walls. It's kind of rude. But depending on how nice your apartment is, how thick the walls are, if you can hear people or not. Well, when you have that shared wall, we know that that wall is going to be the same length for both sides of the apartment, right? Even though it's different sides of the wall, it's the same wall. You could think of it as being shared. Well, that's what this word reflexive means. When we're dealing with triangles, okay, they're not apartments, but you end up with something that's a little bit like an apartment in the fact that they share a side. Now, even though I don't know that this side is congruent for both triangles because of the markings, I do know that if it shares a side, then it's going to be congruent for both triangles. Now, technically, we don't need to mark it, okay? But anytime I see a triangle with a shared side, I can know for sure that this is a shared side. So, do I know these two triangles are congruent? I do, because they share 3 sides in common. So, this would be side, side, side. All right, hopefully this is making a little bit of sense. All right, same here. Notice I have a shared side, so I'd have side, side, side. So I would know for sure that those two triangles are congruent. So that's the first one, side, side, side. The second one, we're going to go through a bunch of these. Today we're just going to look at 3 of them, side, 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 then side, angle, side, and we'll look at one third one here in a minute. So side, angle, side means I have 2 sides and the included angle. Now that's really important. The included angle is the angle that's made up by the 2 sides. Notice if I take this side right here and this side right here, okay, notice what angle they make. They make this one right here. So for example, if I have an angle out here that's not trapped, kind of you can think of a trap between the 2 sides, that would not count as side, angle, side. And we'll look at some examples of that here in a minute. So this one's side, angle, side. Now I would count it like this. I've got a side. Man, my pen does not want to work here. Let me see if I can get it working. All right. I've got a side, I've got an angle, I've got a side. Now notice, I'm not counting these across the triangle. If we go back to this side, side, side example, I'm not counting side, 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 or something like that. I stay on one triangle when I'm counting these. So side, angle, side. If I have side, angle, side, and a matching side, angle, side, thumbs up, those are going to be congruent triangles. Now, it should hopefully make a little bit of sense that these work the way they do. Notice if we remove these lines right here, I'm trying to see if I can get my cursor to work here. All right, here, we'll do this. We'll cheat. All right, so look, if I remove these sides off, right? Okay. If I have side, angle, side on both of these figures, there's no way for those 2 endpoints to move. If I've got to draw my lines from the endpoints, the only way is to end up making 2 triangles that are congruent. So once again, I know this isn't like a proof, but you can kind of visually see why this has to be the case. So let's look at a few more examples of side, angle, side. So here's kind of a straightforward side, angle, side. Let's look at this one. Do we know that these 2 triangles are congruent? I know they don't look congruent, but not quite drawn to scale. So do I know for sure that these triangles are congruent? Well, let's count up what I have. Let's start by marking what I have, the given statements, okay? So I've got a side and I've got a side here that matches the side and side on the other triangle. I don't know about that third side though, right? It doesn't look like there's a way for me to know that those sides are congruent. But what do I have here? I have some vertical angles. Okay, remember vertical angles. This is an angle pair that we've got to know. Okay, vertical angles are angles that are opposite each other created by 2 lines. And I know vertical angles are congruent. So actually, I'm allowed to count vertical angles. So I've got side, angle, side. So these triangles, thumbs up, are congruent by SAS. All right, last one we're going to talk about here today is SSA. Now, SSA does not provide enough information to prove congruence. Now, let me be careful with how I say that. It doesn't mean they're not congruent. It just means that we don't have enough information. Now, you might get the answer option, are these 2 triangles congruent or not congruent? You'll technically the answer is that not enough information, but you obviously would click not congruent. Now, let me see if I can show you how these triangles aren't necessarily congruent. So I know this angle is kind of locked in place, right? And so this side is actually more of, we'll use a dotted line, because the dotted line, it's going up from here and it's just kind of somewhere in this direction. I'm going to have to draw my next side in some length on that line. We don't really know how long. Now, I could set up my triangles so that they're congruent, so I have an angle and a side, but watch this. What if I rotate this angle? Notice this angle's not locked in, so let's rotate this. Okay, and I'm rotating it, and I end up with the same length. Okay, so I could put my 2 marks on here if I wanted to. So I end up with the same length, but in a different location. Something like that. So notice I could actually make 2 different triangles with an angle, a side, and a side. So side-side angle does not give us enough information for congruence, because I could actually come up with 2 different looking triangles with side-side angle. Now, again, when we count this up, side-side angle, that's no good. Or if you count it the opposite direction, you get angle, side, side. Now, an easy way to remember this is if it makes a bad word, don't use it. Okay, side, 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 good to go. Side, angle, side, good to go. Angle, side, side, or side, side, angle, we're not allowed to use that one. All right, so let's look at a couple examples here. Notice here we've got an angle, a side, so I count those up. Now, I don't have any, I should always check for vertical angles and reflexive sides. Do I have any reflexive sides? I do. I have one right here, so let's mark that. Do I have any vertical angles? I don't. So what do I end up with? Angle, side, side, I would say not congruent. Okay, not congruent, or I don't know that they could, I don't know for sure that they're congruent. All right, let's take a look at another one. Are these triangles congruent? And you can try this one on your own if you want. So I've got a side. Notice if one side's 90 degrees, the other side's going to be 90 degrees, right? Because that's how supplementary angles work. So that's going to be an angle and a side. Do I have any reflexive sides? I sure do. So I've got a side and an angle and a side. So this is going to be SAS. Now notice the only difference between angle, side, side, and side, angle, side is that the angle is trapped between the 2 sides for side, angle, side. When we look at this, if this angle was actually over here, that would be side, angle, side. So it's really important that we recognize the angle has to be between the 2 sides for side, angle, side. Okay, same one here. Let's see if I want to do any more of these. Okay, last one here. Again, reflexive side. We get side, angle, side. All right, so that wraps up our lesson for today. Do IXL K.1. Try it. You should be able to get that to 100. Let's take a look at what that looks like real quick. All right, so it's going to look something like this. A lot of this is about getting the letters in the right order. So it's pretty obvious that these are the 2 triangles congruent. The first triangle doesn't matter how you put the letters in. The second triangle, you just need to match up the letters. So W here is going to match with T, X is going to match with U, and then V matches with S. All right. Notice you get double points on this, so it's not going to take long to get to 100. A lot of it's just about matching the letters up correctly. So if you have any questions, as always, shoot me an email, and I will see you soon.